Hi, class. Okay, this time we'll learn how to solve for a more complicated kind of equation. We solve for a radical equation with two radical quantities inside the equation. Previously, we learned how to solve for a radical equation with one radical quantity. But this time, we have two. So once again, we can't raise each term to the second power and say that the radical or the square root in this case disappear. We can't do it. If we do that, it would not hold for the equality of the equation. But we have to, once again, we have to isolate one radical quantity, but because we have two, so we can pick any radical quantity to isolate. So for example, I will isolate the second one. I will isolate the square root of 2x plus 3. So I am going to subtract the entire radical here to both sides of the equation. Or may I say that if I move this entire radical quantity to this side, the coefficient will be the opposite. In this case, the coefficient is 1. When you bring it over, it turns out to be negative 1 radical of x plus 1. So go ahead and do that. So I am going to subtract the radical x plus 1 to both sides of the equation. I have this left equals 1 minus the radical of x plus 1. And then I am going to raise the left side to the second power, and I will raise the entire right side to the second power. The reason for me to do that, because I want to eliminate this square root. So I am going to raise the left side to the second power and the right side to the second power. For the left, I only have 2x plus 3. And for the right, I have to perform a minus b to the second power. In this case, a is number 1. b is the square root of x plus 1. So I have a squared, 1 squared, plus 2. I am sorry, due to the negative here, we have minus 2 times a times 1 times b, x plus 1, plus b squared, square root of x plus 1 to the second power. So this is the result of the foiling of 1 minus square root of x plus 1 to the second power. Okay? And then we simplify the right side a bit. 1 to the second power is 1 minus 2 times 1 times this, 2 square root of x plus 1, plus square root of x plus 1 to the second power is x plus 1. And then we have to isolate this radical, same as we did for the other one. But before doing so, I am going to combine 1 and 1. I have 2 minus 2 x plus 1 plus x, 2x plus 3. Now, we will isolate this. So I am going to minus x to both sides of the equation, and minus 2 to both sides of the equation. And on the left, I have 2x minus x would be x. 3 minus 2 would be 1. And on the right side, I have negative 2 times x plus 1. And then we raise the right side to the second power. And we raise the left side, x plus 1 to the second power. Okay? And then the left, I am going to perform a plus b to the second power. So I have a squared plus 2 times ab plus b squared. So in this case, I have a is x squared, plus 2 times x times 1, 2x, plus 1 to the second power is 1. On the right side, the negative 2 to the second power would be positive 4 times the square root of x plus 1 to the second power is simply x plus 1. And work it out. Left side, I have x squared plus 2x plus 1. And the right side, I have 4x plus 4. And then we want to solve for the unknown from here. We have to rearrange terms. So I'm going to shift everything to the left side of the equation. I have x squared. I subtract 4x. With 2x, I have negative 2x. I minus 4. With 1, I have negative 3 equals 0. And from here on, we can solve by zero factor property. X minus 3 plus 1. And we say x minus 3 equals 0, or x plus 1 equals 0. X equals 3, or x equals negative 1. And then we have to check for extraneous solution. We go back to the beginning of the equation. I am going to do some mental check. I am going to do it very slowly. We are running out of space here, so I'm going to work with you mentally here. I'm going to replace x by 3. On the left side, I have 3 plus 1 is 4. Square root of 4 is 2, plus 2 times 3 is 6, plus 3 is 9. Square root of 9 is 3. So here I have 2, here I have 3. 2 plus 3 is 5. And 5 is not equals 1. So therefore, x equals 3. No good. It is extraneous. Now we work with negative 1. Mental math again. Minus 1 here, and I substitute x by minus 1. The first radical quantity, I have negative 1 plus 1 is 0. Square root of 0 is simply 0. Over here, 2 times negative 1 is negative 2, plus 3 is 1. Square root of 1 is 1. And that equals 1. So therefore, x equals negative 1. Check. It is a good answer. Okay, let me recap how to solve for a radical equation with two radical quantities in the equation. We isolate one radical quantity. Then we raise that to the second power. And after you do that, you still have one more radical quantity on the other side of the equation. And then we isolate that radical quantity. Okay? And then we continue to raise to the second power again. And after that step, I end up with a very nice equation with no more radical quantity in it. And then if it is nonlinear equation, then we're going to rearrange all the terms to one side of the equation, such as this, and we check for solving by zero factor property. Then you work them out, okay, depending how many solutions you have. If you have two solutions, you check for extraneous solutions by substitute the solution back to the very beginning of the equation, and to make sure it check with the equality of the equation. And then that turned out to be a good solution. If it's not, it is extraneous solution.